Assalamualaikum warahmatullahi wabarakatuh. Okay, this is our new chapter entitled Redox reaction. Redox actually it comes from word RED is a reduction or X is a oxidation. So now we want to learn on reduction and oxidation process. Okay, this is the lesson outcome or the subtopic in this chapter. First, define redox reaction. Okay, so you need to know how to define or definition of this redox reaction. Second, determine the oxidation number of any element in a compound. So this is the calculation of the oxidation number of the element in the compound. Third, identify the oxidizing and reducing agent in a redox reaction. So in the redox reaction, you can determine which substance is the oxidizing and which substance is reducing agent. Next, balances redox reaction in acidic or basic medium. And lastly, identify characteristic and example of redox reaction. So this is all the subtopic in this chapter. Okay, why redox? Why reduction and oxidation process? Why this reduction and oxidation process is very important? Actually, it is very important in our daily life. It is very important in the application of combustion and explosion, in oxidation that is in spoiling and aging. For example, if we have an apple, our apple is spoiled and then aging process. In electrochemistry and batteries, okay, inside the batteries actually there is a redox reaction occur. And then for the metal surface, okay, a lot of metal surface on the surface it will oxidize. So this is all the reduction and oxidation process, okay, that occur in our daily life. So what is redox reaction? So redox reaction, okay, redox actually comes from word reduction. It's come from the term reduction and then oxidation. So the short form is redox. Okay, redox is a reduction and oxidation reaction. So a redox reaction is one involving both reduction and oxidation process. Okay, it occurs simultaneously. Mesti ada both reduction and oxidation process. So what is the oxidation process? So oxidation means loss of electrons. Okay, loss of electron or electrons or increase in oxidation number. So that why we call it as oxidation process. And then reduction process. Okay, reduction is gain of electron or decrease in oxidation number. Okay, so this is the definition of oxidation and reduction reaction. So how we represent the redox reaction? So we represent redox reaction using the half reaction. So half reaction. So this is the half equation reaction. So half equation or half reaction are ionic equation to describe either the gain or the loss of electron during the redox reaction. So this half equation means that we have a chemical equation, but this is only the half equation. That is, for the first equation, it describes gain of electron, and the second equation, it describes loss of electron. I give an example here. Okay, for the first example is oxidation reaction. This is half reaction for the oxidation reaction. So electron loss. Okay, from this equation you can see that this zinc, it lost 2 electron to form zinc 2 plus, because we know that zinc, it have 2 electron valence. Okay, so zinc have 2 electron valence, so it can lose 2 electron. Okay, it can lose 2 electron to become zinc 2 plus plus 2 electron. And then the second equation is reduction reaction. Okay, so this one is electron gain, so it means that it accept electron from the other atom from the oxidation reaction. For example, here I have copper 2 plus. Okay, so this is copper 2 plus. Okay, because the shell is not enough electron, so it can accept 2 electron. Okay, from the other atom to become copper. Okay, so this is half equation for the oxidation reaction, and then this is a half equation for the reduction reaction. Okay, oxidation reaction and reduction reaction. And then from these two equation, okay, because this one we call it as half reaction, actually we can write a full equation. Okay. Okay, lastly, we can write the full equation. Okay, from here, you can cancel these two electron. You can cancel these two electron. These two electron, you will get full equation. You just add the oxidation half equation and the reduction half equation. Okay, zinc plus copper 2 plus, zinc plus copper 2 plus to become zinc 2 plus plus copper. Because these two electron you can cancel out. Okay, so this is the half reaction. Okay, for the oxidation half reaction, reduction half reaction, and then after you add these two equation, you will get full equation for the half reaction, full equation. Okay. Okay, for the oxidation and reduction reaction, that is this redox reaction, you need to know how to calculate the oxidation number. Okay, so this is the calculation process. So you need to know how to calculate the number of oxidation for some atom. Okay, so oxidation number. Each atom in a molecule or ionic compound is assigned an oxidation number or oxidation state. So for each atom, actually there is a oxidation number. It have the oxidation state. So this oxidation number signifies the number of charges the atom will have in a molecule, ionic compound, if electron were transferred completely. So for each atom, for example, I give one example here. There is zinc chloride. Okay, I give an example here, zinc chloride. So this zinc chloride, it have an oxidation number. This chlorine also have an oxidation number. Then you need to know the oxidation number for this zinc and this chloride. Okay, and then you need to follow some rule for the oxidation number. Okay, this is the general rule for the oxidation number. Okay, and then rules for the specific atom or periodic table or group. So you need to remember all these rules. Okay, for the first rule, for an atom in its elemental form, for example, sodium, oxygen, chlorine, the oxidation number is equal to 0. Okay, all the atom. Okay, I said here all the atom. So it means that it is in neutral atom. For example, I give here Na. So an Na here is a atom. So this atom, the oxidation number is equal to 0. Okay, this atom is equal to 0. Or if it is in elemental form, okay, for example, oxygen. So oxygen element form is O2. So it is equal to 0. Or chlorine. Okay, chlorine in element Cl2. So oxidation number also is equal to 0. So for second rule, for a monoatomic ion, oxidation number is equal to ion charge. Okay, for monoatomic ion, I give an example here, chlorine, Cl-. Okay, so Cl-, it refer to its ion charge. For example, this chlorine ion is negative. So it's referred to this oxidation number for this chlorine ion is -1. Oxidation number, okay, so it's equal to -1. Okay, the third rule, the sum of oxidation number for the atoms in a compound is equal to 0. And the sum of the oxidation number value for the atom in a polyatomic ion is equal to the ion charge. Okay, so now we want to calculate the oxidation number value for the total atom in a molecule. So it should be equal to 0 if it is in a neutral atom. Okay, or in polyatomic ion, it should be equal to the ion charge. For example, nitrate ion. So nitrate ion, because we know that nitrate ion is NO3 minus. So you should equal to -1. Okay, so it refer to the charge of the molecule. And then this is the rule for the specific atom in a molecule. Okay, for group 1A, for example, sodium, lithium, potassium. So all atom in the group 1A, the oxidation number is equal to +1. So group 2A, oxidation number is equal to +2. Okay, positive 2. For hydrogen, okay, for hydrogen is of course is positive 1 because it have 1 electron valence, so it should be positive 1 when it combined with non-metal. Okay, when it combined with non-metal. For fluorine, oxidation number is negative 1 when it combined with metal and boron. Okay, for oxygen, negative 1 when it is in peroxide form. Okay, in peroxide, oxidation number for the oxygen is negative 1. And then, for oxygen, for other compound, okay, oxidation number for oxygen is negative 2, except with fluorine. And then, for group 17, is negative 1. Okay, negative 1, for example, chlorine ion, bromine ion, when it combined with metal, and non-metal except oxygen, all halogen lower in the group. All here is a oxidation number should be negative 1. Okay. Okay, this is an example for the calculation of the oxidation number. Okay, for the first question, find the oxidation number of carbon in Na2CO3. Okay, sodium carbonate. So, you want to calculate the oxidation number for this carbon. Okay, I want to calculate the oxidation number for this carbon. So, we know that, okay, Na is a group 1. So, group 1, okay, from these rules, we know that for the group 1, oxidation number is positive 1. So, here you can see that this oxidation number for Na is positive 1. Because we have 2 atoms here, so 2. So, 2 multiplied with positive 1. Plus carbon, because we want to find this oxidation number for the carbon. Plus 3. Okay, 3. Why 3? Because oxygen here we have 3. And then multiply with negative 2. Okay, because the oxidation number for the oxygen is negative 2. Okay, from here you can see here, oxidation number for the oxygen is negative 2. So, and then you need to equal to 0. Why 0? Because this molecule is a neutral atom. Okay, because you can see here, from this general rule, the sum of the oxidation number value for the atom in a compound is equal to 0. Okay, so for this compound, you should be equal to 0. And then you can solve this equation. Okay, C minus 4 equal to 0. So C is equal to positive 4. So oxidation number for this carbon, C, is equal to positive 4. Okay, I give another example here. Find the oxidation number of Mn in MnO4 minus. Okay, so I want to find the Mn, oxidation number for this Mn. So Mn plus, okay, because I want to find Mn, just write Mn here, plus 4 because this is this oxygen have 4 atom. So I just write 4 here. And then the oxidation number for this oxygen is equal to 2. Okay, so multiply with 2. Not 2, negative 2. Okay, because oxidation number for oxygen is negative 2. Then equal to negative 1. Why negative 1? Okay, because this molecule, okay, is a polyatomic ion. So you must equal to the charge of this molecule. Okay, you need to follow this rule. The sum of the oxidation number values for the atom in an polyatomic ion is equal to the ion charge. So it means that you need to equal with the ion charge, that is negative 1. And then you proceed here to solve this equation. So Mn minus 8 equal to negative 1. So Mn equal to positive 7. So this is the oxidation number for Mn, positive 7. Okay, example 2. Identify the oxidation number of all the atoms in HCO3 minus. So we want to find the oxidation number for hydrogen, carbon, and oxygen, all the element in this compound. So for the first one is hydrogen. So hydrogen, there is rules inside this table. Okay, for the hydrogen is number 3. That is oxidation number is positive 1. So that's why we get the oxidation number for the hydrogen is equal to positive 1. And then carbon, okay, there is no carbon inside this rule. Okay, so it means that we need to find this carbon, the oxidation number for this carbon. And then oxidation number for oxygen. Okay, so inside this table there is about the oxygen. So oxygen, oxidation number is equal to negative 2. Okay, negative 2. All other compounds except with F. Okay, so oxidation number for oxygen, it should be negative 2. Okay, it's negative 2. So you need to calculate the oxidation number for carbon because there is no carbon inside this rule. Okay, tak tahu. So we need to find the oxidation number for carbon because we already know about the hydrogen, we already know about the oxygen. So now I want to calculate the oxidation number for carbon. Okay, so hydrogen we know it is a positive 1. Carbon, okay, just write carbon here because we need to calculate the oxidation number for carbon. Plus 3. Why 3? Because this one is a 3. Because this is the the number of oxygen is equal to 3. So 3 multiply with negative 2 because oxidation number for oxygen is negative 2. Okay, so 3 multiply with negative 2 here. So equal to negative 1. Why negative 1? Because this compound, okay, it have a negative 1 charge. Okay, it follow this rule. The sum of the oxidation number values of the atom in polyatomic ion, okay, this is the polyatomic ion, is equal to the ion charge. So it means that you need to equal with ion charge. Okay, so this ion charge is equal to negative 1. So you need to equal with negative 1. And then you just solve this equation. So say minus 1 equal to minus 1. Okay, next is you calculate that carbon is equal to positive 4. Okay, now we already calculate about the oxidation number for each element inside the HCO3 minus. Okay, so oxidation number for the hydrogen is positive 1, oxidation number for the oxygen is equal to negative 2, and then oxidation number for carbon is equal to positive 4. Okay, this is how we calculate the oxidation number. Okay, now we go to the definition of redox reaction. Okay, definition of redox. Okay, redox reaction actually can be defined into these 3 definitions. That is in terms of electron transfer, oxygen transfer, and hydrogen transfer. So we can define the redox reaction into these 3 terms. Okay. Okay, for the first definition, so we want to define the oxidation and reduction reaction in terms of electron transfer. Okay, for the first one, oxidation. So oxidation is a loss of electron by a substance. So it means that we have a substance, it lost an electron. For example, I have this zinc. So from here you can see that this zinc actually it lost electron, it lost 2 electron to become zinc 2 plus. Okay, so this zinc it lost 2 electron to become zinc 2 plus. For reduction reaction, it is gain of electron by a substance. So substance, it gain electron. For example, here Cu2 plus. Okay, so Cu2 plus. Okay, so this Cu is not enough electron because it's already lost electron. So this Cu, it can accept 2 electron from the outside. Okay, the Cu2 plus can accept 2 electron from the outside. These 2 electron, it will become Cu. Okay, copper. So it means that this is a reduction process because it gained electron. And then this one, it lost electron. So this is the oxidation process. Or when we talk about the oxidation number, it is increase in oxidation number. For example, the zinc. So oxidation number for zinc is equal to 0 because all the neutral atom, the oxidation number is equal to 0. And this oxidation number is zinc 2 plus. Okay, so this oxidation number is positive 2. Okay, for this zinc 2 plus. So from here you can see that the oxidation number is increased from 0 to positive 2. So this reaction is a oxidation reaction. And then from here, copper 2 plus. We know that copper 2 plus, the oxidation number is positive 2. And then for copper is 0. From here you can see that oxidation number is decreased from positive 2 to 0. Okay, so this process is a reduction process. So it means that in terms of electron transfer, oxidation is a substance that lost electron. Okay, oxidation is a substance that lost electron and increase in oxidation number. So all the substance that it can increase oxidation number, lost electron, it is a oxidation process. And then for the reduction process, the substance, it can gain electron, it can accept electron. Okay, all the process that gain electron or decrease in oxidation number, we call it as reduction process. Okay, the second definition is in terms of oxygen transfer. So, definition of oxidation and reduction in terms of oxygen transfer. Okay, for the first one, oxidation. So, oxidation is defined as gain oxygen. Okay, a substance that gain oxygen. Okay, when the substance gain oxygen, we call it as this substance undergo oxidation process. Reduction. So reduction means that the substance that can lose oxygen. Okay, the substance that can lose oxygen, we call it as reduction process. I give an example here. I have the iron oxide. Okay, iron 3 oxide plus carbon monoxide. It will form iron plus carbon dioxide. Okay, from here, iron oxide to iron. Okay, iron oxide to iron. This one is a reduction process because for the reactant, it have an oxygen. But for iron, there is no oxygen. So, it means that this iron oxide, it lost oxygen. So, this process is a reduction process. Okay, because iron oxide is reduced. So, it lost oxygen. But for this carbon monoxide, okay, this carbon monoxide is undergo oxidation process. It gain oxygen. It gain an extra oxygen. So, for example, here I have the carbon monoxide, only CO. Now, it becomes CO2. So, it gain oxygen. So, this process, we call it as oxidation process, or carbon monoxide is oxidized. Okay, this one for the third definition of the redox reaction, oxidation and reduction reaction in terms of hydrogen transfer. Okay, in terms of hydrogen transfer. Okay, oxidation. Oxidation. We want to define the oxidation process as loss of hydrogen. Okay, oxidation means that a substance that can loss of hydrogen. Reduction is a substance that can gain of hydrogen. I give an example here. Okay, CH3CH2OH. Okay, from here you can see that hydrogen here is 3, 2, 5, 6. 6 hydrogen. And for this CH3CH4, we have only 4 hydrogen. So it means that this CH3CH2OH, it lost hydrogen. So this process is oxidation process. Okay, as a summary here, we can define the oxidation and reduction reaction in terms of electron transfer, oxygen transfer, and hydrogen transfer. Okay, for the first definition, there is electron transfer. Oxidation is a substance that loss of electron or increase in oxidation number. Reduction means that a substance that can gain the electron, it can accept electron, or it should be decreased in oxidation number. Okay, when we talk about the oxygen transfer, oxidation means that the substance that can gain oxygen or can accept oxygen. For the reduction process is a substance that can lose oxygen. Okay, lose oxygen. Last, in terms of hydrogen transfer, oxidation is loss of hydrogen. Okay, loss of hydrogen. But reduction is gain hydrogen. Okay, now we go to the oxidizing and reducing agent. Okay, oxidizing and reducing agent. So now we will talk about the agent. Okay, reducing agent. Reducing agent is the species. Okay, why species? Because this is we talk about agent. Okay, something or substance. Okay, it should be the species, which is being oxidized itself or electron donor. So reducing agent is a species that being oxidized. Okay, it's difference here. Reducing species that being oxidized. Oxidizing agent is a species which is being reduced or electron acceptor. Okay, oxidizing agent is a species which is being reduced. Okay, I give an example here for the oxidizing and reducing agent. 2 Mg plus oxygen, it will form 2 MgO, magnesium oxide. So which one here is a reducing agent and oxidizing agent? Okay, magnesium is oxidized. It acts as reducing agent. Okay, so this magnesium is oxidized. So this Mg, it is oxidized. Why this is oxidation process? Because from here you can see that the oxidation number for Mg is 0. So oxidation number for MgO is equal to positive 2. Okay, if you calculate the magnesium oxide oxidation number. So for this magnesium is positive 2. So 0 to positive 2, it means that increase in oxidation number. So this is oxidation process. So that's why magnesium is oxidized. Okay, because it increased the oxidation number. So because this magnesium is oxidized, it acts as reducing agent. Because reducing agent is the species. Okay, species that being oxidized. So this magnesium is reducing agent because it being oxidized. And it undergo oxidation process. So it donates electron to oxygen and cause oxygen to be reduced. Okay, next is oxygen. So oxygen is reduced, okay, O2 to O. So O2 here is equal to 0. Oxidation number for O2 is equal to 0. And for oxygen, okay, I talk about oxygen, not magnesium. So oxidation number for the oxygen is negative 2. So from 0 to negative 2 means that it is reduction process for oxygen to magnesium oxide. So this oxygen is reduced. So when it reduced, it acts as oxidizing agent. Okay, because the definition of oxidizing agent is a species which is being reduced. So it accepts electron from Mg, causing Mg to oxidize. Okay, so this is an example for the reducing agent and oxidizing agent. Okay, I give another example. Identify the oxidizing agent and reducing agent in each of the following 2Al plus sulfuric acid. It will form aluminium sulfate plus hydrogen. Okay, from here you can see that this 2Al is the oxidation number is equal to 0. Al2 is positive 3. Okay, Al. We talk about Al. Okay, now Al. We compare the oxidation number for Al here to Al, and this Al in Al2O3. So from here you can see that from 0 to positive 3 is increase in oxidation number. This one we call it as oxidation process. So when it undergo the oxidation process, it is a reducing agent. So this Al is a reducing agent because it undergo the oxidation process, or this species is being oxidized. Okay, when we talk about the agent, it should be the substance. Okay, for example, aluminium. Okay, next is oxidizing agent. Okay, sulfuric acid. Okay, this sulfuric acid, when you compare the hydrogen, okay, I want to compare the oxidation number of hydrogen, is positive 1. Okay, it's positive 1. If you calculate the oxidation number, okay, we learned this one previously, to calculate the oxidation number. Okay, so to calculate the oxidation number for the hydrogen, so H2 here is equal to positive 1. If you calculate the oxidation number for this hydrogen, is equal to positive 1. And then this hydrogen is equal to 0. So from here you can see that it is decreasing in oxidation number from positive 1 to 0. So because this one is decreasing, okay, this is because of it decrease in oxidation number. So this is the reduction process. Okay, from H2SO4 to 3H2 is a reduction process. So this H2SO4 is a oxidizing agent. Okay, because this species is being reduced. Okay. Okay, next example. Redox reaction occurs when gold ion Au3+, react with iodide ion I- in acidic solution. Predict the oxidizing agent and reducing agent. Okay, I give an example here. I give an chemical equation here. This is Au3+, okay, gold 3+, plus I-, so it will form Au plus I2. Okay, when you calculate the oxidation number for Au2+ is equal to positive 3. Au equal to 0. Okay, so positive 3 to 0. So it means that it is reducing or decreasing in oxidation number. So when decreasing in oxidation number, it is reduction process. Okay, for Au2+ to Au, this one is a reduction process. So this Au, okay, because this is a reduction process, this is the oxidizing agent because it is the species is being reduced. Okay, terbalik. Oxidation is reducing agent. Oxidizing agent is a reduction process. So here, because this is a reduction process, okay, so this Au3+ is a oxidizing agent. And then I- to I2. So I-, if you calculate the oxidation number, is equal to negative 1. I2 is equal to 0. Okay, so it is increasing in oxidation number. So increasing in oxidation number, it is oxidation process. So this I- is oxidized. So this oxidized, it is a reducing agent. Okay, next example. Identify the species oxidized, the species reduced, the oxidizing agent, and the reducing agent for the following reaction. So I have Fe2+ plus 3H plus NO3 minus to form Fe3+ plus NO2 plus H2O. Okay, for Fe2 plus to Fe3 plus. Okay, Fe2 plus to Fe3 plus. So this one is a positive 2 oxidation number. Fe3 plus is a positive 3 oxidation number. So increasing in oxidation number is oxidation process. So because this is oxidation process, this Fe2 plus is a reducing agent. Okay, for NO3 minus to NO2, if you calculate the oxidation number for nitrogen, is positive 5. And then, oxidation number for NO2 is a positive 4. Okay, and nitrogen only. We talk about nitrogen. Okay, positive 4. So, from here, you can see that it is decreasing in oxidation number. So, when decreasing in oxidation number, it is reduction process. So reduction process, it is oxidizing agent. Okay, that's all for today. Thank you, class.